Okay, so for question D, we need to find the maximum amount of unprocessed gravel at the plant during the hours of operation, and the hours of operation are 0 to 8. So to do this, we need to do the closed interval method, and our 2 points on the interval are 0 and 8, as I said, but to find the third or fourth or however many values, you need to use the derivative and find the derivative equals 0. And the derivative, you do this by taking the amount. You need to find the amount at time t and the starting amount plus the integral from 0 to t of the unprocessed rate plus or minus the processing rate with respect to x. And you need to use a dummy variable. Make sure you do this because you cannot have g of t and go from the integral from 0 to t. It will just not work out that way. And this is the equation, the first equation, and then we need to find the derivative of it. So the first equation will be 500, which is the starting amount, plus the integral from 0 to t of g of x, because we use that dummy variable, minus 100 with respect to x. And we take the derivative of this, and the derivative of constant is 0. And then using the fundamental theorem of calculus, we take the t down and we get g of t is minus 100 is the derivative. And then we set that equal to 0 and go from there. So g of t is 90 plus 45 cosine of t squared all over 18 minus 100 equals 0. Then we can take this and get 45 cosine by simplifying. We get rid of the 90 and make it negative. 90 minus 100 is negative 10 equals 0. Then we graph this on the calculator, and you can do that on your own, and you will get this 0 to 8, and since that's the workday, that should be your x values, and then the y value should be negative 50 to 50, so you can plot the whole thing, and then you graph a of t, which will look something like this, and then you use the calculator to find the point of, or the 0 on this graph, and you'll get 4.92348, and you store this in your calculator, and you go back up to your chart that you made, and you plug this in, and you find then you plug these in to the original function, and you plug all these in, and a of 0 is equal to 500, which is your starting. A of 4.92348 is equal to 500 plus the integral from 0 to 4.92348 times g of t, and then with respect to t, and you will get 635.376. That's rounded off, and then a of 8, you do this, you want to get all three. You get 500 plus the integral from 0 to 8 of 45 cosine of x squared over 18 minus 10, which is just g of t dx. I'm just writing that out one more time. And you'll get 525.551. And so with that, you get 635.376, and that's the maximum right there. So the maximum amount of unprocessed gravel is 635.376, and this occurs at t is equal to 4.923.